Today, we are converting camelCase strings into kebab-case strings. We are determining the character in a string with the longest consecutive repetition. We are extracting file names. We are calculating statistics from a running competition. And then we are determining how many IPv4 addresses can be found within a range of 2 IPv4 address strings. Hello world, and we are dealing with string katas on today's episode of Versus Codewars. And I hope everyone is having a wonderful day today. The katas in today's episode will be revolving around strings. And we begin our warm-up segment today with a function that returns a greeting statement that uses an input. The program should return, hello name, how are you doing today, as shown in the kata instructions here. Let's go ahead and give this one a try here. Alright, const greet. And we have our name here. And what we're going to do with that name, we are going to do something called a template string. If in JavaScript you can use backticks to indicate a template string rather than the apostrophe or the quotation marks. And what you can do in a template string, you can do something like this. Hello, $ curly brace name. How are you doing today? Now, what you see here is called a placeholder, and this placeholder will be replaced by the variable or statement that is inside this placeholder here. In this particular case, the name that we pass in here. So let's say we go ahead and greet ourselves here. Console.log greet, and we pass in Dennis for the name here. Instead of hello name, how are you doing today, it will say hello Dennis, how are you doing today? Let's see what that looks like here. Node warmup return string. And it will say hello Dennis, how are you doing today? Alright, let's go ahead and punch this into Codewars here. And that is how template strings work in JavaScript. Let's go ahead and hit attempt. And we are good on that. For our next warm-up kata, our goal is to create a function which answers the question, are you playing the banjo? If your name starts with the letter R or lowercase r, you indeed are. Let's go ahead and give this one a try here. Alright, const are you playing banjo? And we have our name right here. And we have to figure out whether we are playing the banjo by determining if our name begins with an R. So what we'll go ahead and do, first we need to go ahead and convert our name to lowercase here, because this check will be case insensitive here. So we'll do name equals name dot to lowercase. And then we'll go ahead and get the first character from that name. Const first char, name at index 0. Just like what we can do with arrays, we can also index characters in a string using the bracket notation here. In this particular case, we are looking for the first character in the name that we pass in. So, what we'll go ahead and do from here, actually what we need to do, this name here will actually be part of the return. So what we'll go ahead and do here, we're going to go ahead and take the name, convert that to lowercase, and then we'll take the return string here and get the first character from that. Anyway, what we're going to do, we're going to return the return of a ternary statement, a ternary expression here. We are going to return if name, or rather if first char is equal to the letter R. Remember, we are changing this to lowercase, so if this first char is a capital or a lowercase r, this will change it to a lowercase r regardless. So if we are going to return, if first char is equal to the letter r, we are going to return this string here. Name plays banjo. Otherwise, we will return another string. Name does not play banjo. Again, we are using the template string I told you about in the first warm-up kata. Alright, I'm going to go ahead and punch this into Codewars to see what this looks like. And we are good on that. For our next warm-up kata, we are playing around some more with anagrams. An anagram is the result of rearranging the letters of a word to produce a new word. Anagrams are case insensitive. The goal of this kata is to return true if two given strings are anagrams of one another. Let's go ahead and give this one a try here. Const is anagram. And we are going to have two strings, first and second. And what we're going to go ahead and do with these strings here, probably the best way to determine if these two are anagrams is to sort the characters of these two strings into ascending order and then check them against one another here. Alright, what we're going to go ahead and do first, it can be safely assumed that an anagram between two words, and if two words are anagrams, excuse me, those two words will have the same exact number of letters. So what we can do right off the bat, if first dot length, we're going to get the length of these two characters and compare them against one another. And if these lengths are not equal, then we know this is not an anagram, so we'll return false. Alright, what we'll go ahead and do from there, we are going to go ahead and take these two strings, get the characters from them into an array, and then sort them in ascending order. And what we'll go ahead and do there, to do that, we are going to go ahead and do this. Const first chars, we're going to do a destructuring and a spread assignment operation here. We are going to spread the characters of our first string into an array, as you can see right here. This spreads the characters out, and the brackets in between this will put those characters into an array. We're going to take that array, we're going to sort that into alphabetical order with the sort method. And I do not think this will cause any issues if we don't provide a sorting function here, because the sort method, if I'm not mistaken, natively sorts characters into alphabetical order. Now, we need to take that resulting array. I think we're going to change this to first sorted here. We're going to go ahead and take the characters in this array and join those back in together into a string with the blank string separator. And we are going to go ahead and do the same with the second string here. Second, not sort, not join. Finally, we can go ahead and compare the two sorted strings here. Return first sorted is equal to second sorted. This should return true if these sorted strings are exactly the same. Let's go ahead and test this out here. We are going to need to convert these to lowercase. I'm going to go ahead and do that up here. Alright, let's go ahead and test this out here. Console.log is anagram. Pass in bucket head and death cube k. Alright, let's test this out here. Node warm up anagram. And this returns false, and that is not what we were expecting here. Let's go ahead and log these sorted strings here. First sorted, second sorted. Oh, okay. We actually need to go ahead and convert these to lowercase before we sort them. That was the issue. So let's go ahead and move that into our destructuring operation here. Let's try that now. Yep, it's now working here. Let's go ahead and punch this into Codewars to see what this looks like. And we are good on that. For our fourth warm-up kata, we are dealing with bumps in the road. Our car is very old and it breaks easily. The shock absorbers are gone, and I think it can handle about 15 bumps before it goes kaput. Unfortunately, my drive is very bumpy. That drive is represented by a string of characters either representing Unfortunately for us, our driveway is very bumpy here. And that drive is represented by a string featuring two characters. Flat road, represented by underscores, and bumps, represented by lowercase n's. The goal of this kata is to work out if we can make it home safely. If it's 15 bumps or under, we are to return a string that says woohoo. And if it's over 15 bumps, we have to return a string that says car dead. Let's go ahead and give this one a try here. Constant bump. Passing our bump count here. And we will return our drive string. And what we will do with that drive string, we need to figure out how many bumps are in this drive. In other words, how many occurrences of the lowercase n are found in our drive string here. And what we can go ahead and do, I have an idea. Well, I think we'll go ahead and strip out all of the underscores here and get the length of the resulting string. So, const bumps only, and we'll do drive string, not replace. We're going to replace any instance of our underscore with a blank string. And then we are going to return the following. If bumps only dot length is less than or equal to 15, we are to return a string that says woohoo. Otherwise, if the length of the bump string is greater than 15 characters, we need to return car dead. Alright, let's go ahead and punch this into Codewars and see what this looks like. We're going to run the test here. And we seem to have a problem here. What's going on? Alright, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, let's go ahead and console.log bumps only, and then bumps only dot length. And let's hit attempt again. Okay, let's go ahead and log our drive string here. See just what it is we are dealing with here. Let's go ahead and copy this string here. And we're going to go ahead and console.log bump. We're going to paste that string into our local solution here and test this out. Node warm-up bumps. It says car dead, but that should not be happening here because we are supposed to be... Oh, right. Oh, right. Whenever we are replacing instances, more than one instance of a single character using the replace method, we have to use a regular expression here. So what we'll do here we're going to catch any instance of the underscore here. And now it works. All right, let's go ahead and reflect that in the Kata solution here. We're going to copy this and paste this in here. Yeah, whenever you are replacing more than one instance of a given character using the replace method, you can't use a string as the first argument. You'll have to use a regular expression. There is another function in JavaScript string object called replace all, which should do the same thing, but with a string argument rather than a regular expression. Let's go ahead and hit attempt here and test this out here. Now we are good on that. But first, let me go ahead and show you how replace all works. I'm going to go ahead and take this regular expression and bring back our string here. Now, as you can see, it should say car dead again. Now, let's replace with replace all here. Let's try that again. And drive string replace all is not a function. Okay, forget I said that. Alright, I will be right back. Give me one moment. Okay, so the reason replace all wasn't working on our machine here is because we are running Node.js version 12.22.9. This method requires Node.js version 15 to work. So just keep that in mind whenever you need to use this function here. If you're using a Node.js version less than 15, you'll need to use the replace method using a regular expression for the first argument. Alright, with that now being said, let's move on to the final warm-up kata here. Alright, we are dealing with colored triangles here. A colored triangle is created from a row of colors, each of which is red, green, or blue. Successive rows, each one containing fewer colors than the last, are generated by considering the two touching colors in the previous row. If these colors are identical, the same color is used in the new row. If they are different, the missing color is used in the new row. This is continued until the final row with a single color only is generated. The different possibilities are shown here in the Kata instructions here. I'll call your attention to this. If you have a color green and green, and the next row, it will become the color green. If in the first row you have a blue and a green, the color in the next row becomes a red. Red and green becomes blue, and blue and red becomes green. Here is an example of a colored triangle, I think with 8 rows here. Alright, the goal of this kata is to determine what color comes out at the end of this triangle here. Alright, we will be given the first row of the triangle as a string, and our goal is to return the final color, which would appear in the bottom row as a string. In the case of the example above, this example here, we would have the given red, red, green, blue, red, green, blue, blue, return the color green. Let's go ahead and give this one a try here. Const triangle. We're gonna we have our first row as the lone parameter here. And what we're going to go ahead and do, we're going to go ahead and keep track of a string here. Let current row, let previous row equal first row. And we're going to go ahead and keep track of a current row here. Alright. Or maybe not. Okay, and what we're going to go ahead and do, maybe an array. Let rows equal, we're going to set that to an array with the first row as its lone element here. And what we're going to go ahead and do, we're going to go ahead and do a do while loop here. do while rows and rows.length minus 1.length is greater than 1. And what we're going to do inside this do while loop here, we're going to go ahead and keep track of a current row string up here. And we're going to keep track of our previous row here. We're going to set that to the element of the row string, the last element of the row string array, just so we don't have to repeatedly type this out here. All right, what we're going to go ahead and do, previous row, we're going to set that equal to rows and rows.length minus 1. And we are going to go ahead and we're going to do a for loop for let I equals 1 instead of 0, because we are going to be comparing the character of this row at the current index with the character in this row at the previous index. I is less than previous row.length plus I. And what we're going to go ahead and do, we're going to go ahead and get the first and second characters here. Const first char equals previous row at I minus 1. And then const second char equals previous row at index I. And what we're going to go ahead and do, first and foremost, if first char is equal to second char, then we're going to go ahead and push that very same char into our current row here. This char here. Now, we're going to handle some else if cases here. Else if first char is equal to B and second char is equal to G for green, blue and green. And then current row plus equals red. Else if first char is equal to red and second char is equal to green. Now we need to obviously need to account for cases where, yeah, okay, that's probably a naive way to approach that here. Maybe if we order that here. All right. That's probably a naive way to approach that here. I have an idea. Let's do a lookup table here. We'll do B G G B R G. No, that ain't gonna work either. Okay, might as well go with the naive approach here. Else if first char is equal to blue and second char is equal to green, then we do current row plus equals red. And we will repeat that if the roles are reversed here and first char is green and second char is blue. Alright. Don't like this approach. I need to find a more efficient way to handle this here. I think we will do that in a future episode of Versus Codewars here. Anyway, red and green is blue. And then blue and red is green. Alright, now at the end of this long block of if statements here, we're going to go ahead and push that current row into our rows array here. And we're going to do that like this. Rows dot push current row. And we are going to continue this as long as the length of the row, the last row in this array, is greater than 1. Alright, now once we get to the end of this do while loop, we should just be able to return rows and rows.length minus 1 here. And that should give us the color at the end of this colored triangle here. Alright, let's go ahead and test this out here. We're going to do a console.log here. Console.log triangle. Oops. And we are going to start that triangle out with this string here. Red, blue, red, green. Blue, red, blue, green, green. Red, 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 blue, green, blue, 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 green, green. Let's go ahead and test this out here. Node, warm up colored triangles. It should give us green here. It should give us green, but actually it's giving us an infinite loop here. What is going on? We're going to do console.log here. Whoa, 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 whoa. Alright, we are not clearing the current row string once we're done with it. My bad. Let's go ahead and try that again here. And we do get green as the return color here. Alright, let's go ahead and punch this into Codewars and see what this looks like here. Run the tests. And we got a problem. What's going on? Expected blank string to equal blue. Yeah, okay. Do need to handle an edge case here. If first row dot length is equal to 1, then we return, or rather less than or equal to 1, then we return first row. I forgot to handle that edge case here. Let's go ahead and try that again here. Copy, paste, run the tests. And we are good on that. That concludes today's warm-up segment. I will see you in the next kata. Given a camelCase string, the goal of this kata is to convert that string into kebab-case. Let's go ahead and give this one a try here. We will be using regular expressions for this one here. And what we will do here is we are going to return camelCase, our camelCase string, replace, and that regular expression is going to consist of the following. Any capital letter here, and we are going to replace that with, we are going to have actually, I'm going to try doing a capture group here. In which case, we're going to encase this bracket here with parentheses here. And we're going to try this. I think the notation for looking up capture groups is the $. Let's try that. We're going to dash $1 here. Alright. Let's go ahead and test this out and see if we're right here. Console.log Kebabize camels have 3 humps. Alright, let's go ahead and test this out here. Node kebabize.js. And we've almost got it here. I think actually we may need to use a matcher function here, a replacer function here. The reason being here is these need to be converted into lowercase here. So what we'll do here, we're actually not going to use the match parameter here, so we're going to use an underscore here. The replacer function in the replace method can actually have more than one argument. And that is especially useful when you're using a regular expression with capture groups here, because whatever is captured in those capture groups here can be referenced in those additional arguments here. In this case, we have 1, and we're going to use P1 for that placeholder here. I'm going to go ahead and, in here, we're going to go ahead and return in a template string, dash P1.to lowercase, to convert this into a lowercase letter here. Testing this out, we should have our string, camels have 3 humps, in kebab-case with all lowercase letters. But before we punch this into Codewars, I want to call your attention to the second example here. And it says camels have 3, the number 3 humps. And it should return camels have humps, leaving out that 3 right here. Let's go ahead and see what we have so far here. And yeah, that 3 is still there. We actually do not want that here. So what we'll go ahead and do, we're going to do another call to the replace method here. And we're going to replace any numerical instance in the string with a blank string. And that would be 0 through 9. And we do need to replace that with a blank string here. And we do have our corrected string, camels have humps. Alright, let's go ahead and punch this into Codewars to see what this looks like here. We're going to go ahead and test these out in our cases here. We're going to hit attempt. We have a problem. What's going on? Oh, okay. Let's have a look at the Kata instructions here. It seems in the case of our failed tests here. Alright, let's go ahead and console.log our camelCase here. Let's try debugging this issue here. Okay, there are instances where there's only one word, like only one word in our camel casing here. And I think that is where we're tripping up here. So we will try this. We will take our camel case here and call no, that would not work. Alright, we'll take the first letter of that. So we'll need to handle some edge cases here. If camelCase is a blank string, we did need to explicitly return a blank string here. Because what we will be doing here is if camelCase, we will take the first letter of our camelCase string here and set that to a lowercase letter. camelCase 0.2 lowercase. Let's see here about that. We're gonna go ahead and pull in this test here. BWTW here. And yeah, we do not want that here. And I have an idea. We're going to go ahead and do a third call to replace here. In this regular expression, we're going to look at the start of the string for a capital letter. And we're going to take, if it finds a capital letter at the start of the string, we're going to convert it to lowercase. And that does give us our correct string here. So let's go ahead and punch this into Codewars to see what this looks like. Still problems. What's going on now? Expect an IB. Alright, let's go ahead and console.log that and see where we're still going wrong here. I'm going to scroll down here until we find a failed test. We have instances where we have numbers here. Oh, yeah. Okay. We need to strip the numbers out before we do the lowercase conversion here. Let's do this one. 8 capital L, L9H. Save that and test this out here. And that gives us the correct result. Let's punch this into Codewars now to see what that looks like. And we are good. Here's another way to implement this Kata solution with a couple different tricks with regular expressions. Pay mind to the code snippet you see to my left here, particularly that first call to the replace method here. You see that caret inside the bracket, that range selector in this regular expression? That indicates a negator here. This basically tells the regular expression to look for anything not within the range of these two characters seen in this range selector here. So basically, in this particular case, anything not within the range of lowercase a through lowercase z. Now, I say lowercase before I mention the I flag near the end of this regular expression here. That is the case insensitive flag. That tells the regular expression to ignore case when it's looking for anything within this regular expression here. So that lowercase a through lowercase z actually becomes lowercase a through lowercase z and uppercase a through uppercase z. Given a string, the goal of this kata is to seek out the character in that string that occurs the most consecutive times in that string. We are to return a pair in this kata solution here. The first element being the character that occurs the most consecutive times in the string, and the second element being the number of times that character occurs consecutively. Let's go ahead and give this a shot here. Alright. We will need a pair for this one. Constant results. We are going to go ahead and set this to our pair here. Set that to a blank string and a number. Or rather, first actually we need to handle some edge cases here. If our string is empty, we'll just go ahead and return a blank string and 0 here. If our string's length is 1, we will go ahead and return our string and 1. So the edge cases are now handled here. Let's go ahead and keep track of the long character and the long count. And that's going to be what's returned at the end of this. Long char, long count. Alright. Let's go ahead and iterate over the string here. For let I equals 0. I plus 1 is less than str.length plus I. And I do I plus 1 is less than str.length because in each iteration of this loop, we are going to be indexing the string at the current index and in the next index here, and we do not want to go out of bounds here. All right, what we'll go ahead and do. Alright, maybe that might not be the best way to approach this here. I have another idea. For const char of str, iterate over every character here. If char is not equal to long char, then we'll go ahead and set a long char to our char and long count to 1. Or rather, count. Maybe not long char, current char maybe. Let current char equal a blank string. Let current count equal 0. And char, we'll go ahead and set our current char to our character. Current count is equal to 1. Otherwise, if it is the current char, we'll go ahead and increment that current count. Any event, if current count is greater than our long count, we are going to go ahead and set our long count to our current count. And we're going to go ahead and set long char to current char. And that should work here. Let's go ahead and test this out here. Alright, let's grab this character here. Console.log, longest repetition. We're going to pass this string in here. We're going to go ahead and test this out here. Node longest consecutive repetition. And that should give us a pair with A and 4, because A is the character that occurs the most consecutive times in this particular string, and 4 is the number of consecutive times that particular character occurs. Let's try another one here. A, B, 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 B. B and 5. How about this one here? Copy, paste. I expect to see you here. Yep. How about A, B, 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 C, D, 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 E, F, F, F. I expect to see B and 3 here. And we do. Alright, I think we're good to punch this into Codewars here. First, let me explain what is going on here. Here we have the Kata solution, longest repetition, and it takes a string as its lone parameter here. Now, if that string is empty, let's handle a couple edge cases here. If this string is empty, we return a pair with a blank string and a 0. If that string has exactly one character in it, then we know that is the character that occurs the most consecutive times in the string. There's only one character in the string. That character only occurs once, so we return the string and 1 in this pair here. We keep track of a few variables here. We keep track of the current character in our the current character we are keeping score of here, and we keep track of a current count here. And then we keep the long character and the long count here to represent which character has occurred the most consecutive times thus far in the string here. We go through each and every character of our string here. If our current character is not equal to our current character up here, then we set this character as the new current character and we reset the current count to 1. Otherwise, we increment the current count if this character is in fact equal to the current character. If as a result of either of these, the current count becomes longer than the long count, we go ahead and set the new long count to the current count and the new long char to the current char. We repeat this process for each character of our string here, and then at the end of it, we return the pair with our long char and our long count. And that should be the character that occurs the most consecutive times in the string. Alright, let's go ahead and punch this into Codewars to see what this looks like here. And we are good. I don't have anything to say about the Kata solution here, but it's kind of interesting for me to note that the Kata instruction to mention that I would run into issues if I attempted to use the array.sort method in my Kata solution here. Looking through the other Kata solutions, I really don't know how that method would factor in to any solution to this Kata. I could really use some insight. If anyone out there has any idea how array.sort could be used in a Kata solution like this, please let me know in the comments section below. Here we are tasked with extracting a portion of a file name as follows. Number 1, assume that it will start with a date, represented as a long number. 2, that date is followed by an underscore. 3, we will then have the file name with an extension. And finally, it will always have an extra extension at the end. I'll call your attention to these examples right here. Alright, here we have our date here, represented as a long number. Then the underscore. Then the file name and extension. And then the other extension at the end. The goal of this Kata is to pull this file name and extension from that string here. Pay mind to these examples here, these example inputs, and then these example outputs here, the expected outputs. Acceptable characters from the random tests include every lowercase and uppercase letter and the underscore. Let's go ahead. We are going to need to use regular expressions and capture groups for this one. Let's go ahead and get started here. Alright, let's go ahead and hit train. Redo. Ooh, this seems to be a class with a static function here. So we'll do class file name extractor. And then we have our static method here, extract file name. And we have our dirty file name here. Alright, what we need to do. Alright, first we need to go ahead and yeah, we will be using a regular expression here. And I think that regular expression will be this, const file name regex. We're going to set that to first it needs to start with the underscore. / underscore, and then in our first capture group here, we are going to have any, I think, letter here. \w plus dot \w plus for the extension. And then a dot to start the other extension here. I think that is the regular expression that this calls for here. Let's go ahead and pull this string from our examples here. And we're going to do console.log file name extractor dot extract file name. We're going to paste this string into our local solution here. Now, in here, I think what we go ahead and do, I think we're going to try doing the match method here. We're going to return file name regex.match, or rather, no, I think actually it's exec. Yeah, I think it's exec. File name regex.exec. We are going to execute this regular expression on our dirty file name here. And we're going to leave it at that for now here. Let's go ahead and see what that looks like here. We're going to go ahead and node extract file name. And that looks like that does give us our file name and our extension here. That's hopeful. Let's go ahead and try this one here. Let's have a look at some of our tests down here. How about this one here? Make a copy. I'm going to paste that in here. Okay, let's go ahead and console result. We're going to take the return exec here and store it in our result here. And we are going to do a template string result. I think it's at result at 1 dot result at 2. We do have file name extension here. All right, I think we are good to punch this into Codewars to see what this looks like here. We're going to run the tests. And as we would have it, we have an error here. File name extractor is not defined. Because I misspelled extractor here. Let me fix that here. Alright, let's try that again here. And we have another problem. What's going on now? Please verify that you are handling well character. Okay, yeah. We also need to handle the dash as well. Alright, we'll go ahead and console.log a result here. Alright, let's go ahead and take that here. Let's first go ahead and console.log the dirty file name and the result of our exec here. Let's hit attempt again. Let's scroll down to where we are erroring out here. Alright, I think what we'll go ahead and do then is alright, we're gonna go ahead and grab this file name extension here. I'm gonna copy that and paste that into our local solution here. We need to handle cases where we have this dash here. And that seems to handle it just fine. Let's go ahead and change this other capture group here, include that dash there as well. No, it's not handling it. Not handling it just fine at all. Let's... Alright, I have another idea here. Let's get a little more explicit here. And do an A to Z, and the dash here. And don't forget to include the plus at the end here. We'll do that same thing here as well. Invalid regular expression. Range out of order of character class. Oh. It's supposed to be a lowercase z here. And we also now need to handle explicit cases of the underscore as well. Alright, that should work. Let's go ahead and punch this into Codewars now to see what this looks like here. I'm going to go ahead and hit test and attempt. And we are still dealing with problems here. First, this seems to be handling it just fine here. Null. Let's go ahead and log our dirty file name here. Console.log dirty file name. And we're going to encase that in a parentheses in our string. We're going to go ahead and alright, we also need to handle numbers as well. Let's go ahead and do that here. 0 to 9. Alright, let's go ahead and take this string here. I'm going to copy this over into our local solution and see what that looks like. The test expected this string right here, and now that we modify our solution here, we now see that string here. Let's go ahead and punch this into Codewars to see what this looks like here. We're going to hit test, of course. We're going to hit attempt, and now we are good. So we know that the dirty file name in our Kata solution is formatted as follows. The date, then an underscore, then the file name, then the dot, then the extension, then another dot, and then the extra extension. Notice that the date and the original file name are always separated by an underscore, and the intended extension and the extra extension are always separated by a dot. With that in mind, we can implement this Kata solution without the use of regular expressions. First, use the string object's index of method to look for the first instance of the underscore. That should always be the underscore that separates the date and the intended file name. Then we use the string object's last index of method to look for the last instance of the period in our dirty file name string, as that should always be the period separating the intended extension and the extra extension. With those indices, we can use the string object's slice method to slice starting at the index of the underscore +1 all the way until the index of that period that we picked up. In so doing, we should get the intended file name and extension without the use of regular expressions. We are the computer expert at a local athletic association at a running competition. Many teams of runners come to compete in this competition, and each time we get a string of all of the race results of every team who has run. For example, I will call your attention to a string showing the individual results of a team of 5 runners. Note that these numbers are separated by a pipe symbol, and each entry is separated by either a comma or a comma and a space. Each part of the string is of the form H pipe M pipe S, where H is for hours, M is for minutes, and S is for seconds. And each of these numbers are positive or a null integer represented as strings with 1 or 2 digits. Substrings in the input string are separated by a comma or a comma and a space, as I mentioned before. To compare the results of the teams, we are asked to give 3 statistics: the range, the difference between the maximum and the minimum, the average, that sum of these times divided by the total number of times, and the median, which is a number separating the higher half of a data sample from the lower half. The median of a finite list of numbers can be found by arranging all of the observations from the lowest to the highest value and picking the middle one when there is an odd number of observations. However, if there are an even number of observations or an even number of numbers in the array, so to say, then we have to calculate the median, by taking the 2 middlemost values and calculating the median between them. The goal of this kata is to return a string giving these 3 values in the same format as we mentioned before: hour pipe, minute pipe, second pipe. Alright, let's go ahead and give this one a shot here. Alright, const stat. We're going to have our string here. Alright, as I mentioned before, this string is going to contain our times here. Hours, minutes is separated. Hours, minutes, seconds, pipe separated, and each time comma or comma space separated here. I see ourselves needing the help of a couple helper functions here, but first let's go ahead and take this string here into a console.log stat. We're going to go ahead and pull these in here. And for good measure here, I'm going to omit the space from a couple of them here. First, we need to go ahead and separate these times into separate entries here. And we're going to do that by doing this. Const times equals str.split. Instead of a token string, we are going to need to use a regular expression here, because some of these are separated by commas, but some of them are separated by a comma and a space. So we're going to do a comma and an optional space here. Alright, we're going to go ahead and return that for now. And we are going to go ahead and test this out and see what that looks like here. Node athletic statistics. And we have... yeah, let's try this then. And we should now have our times separated into an array right here. Okay, I think we're going to need to get the seconds from each of these times here. And that is where the first of our helper functions is going to come into play. We're going to do const get seconds. We're going to pass in hours, minutes, seconds here. And what we're going to go ahead and do here, we're going to return hours times, there are 3,600 hours in a second here. We're going to do 60 times 60 plus minutes times 60 plus seconds. And that should get us the number of seconds into this particular combination of hours, minutes, and seconds here. Let's go ahead and test this out here. We're going to do times.map. We're going to do our time here. And we are going to go ahead and now these are going to come up as a string here. So I think we'll try doing this. Parse we're going to run each of these through the parse int method here. That here, parse int here. All right, what we're going to go ahead and do, we're going to do get seconds, and then we're going to take the time, split it using the pipe character as a separator here. Whoops. Use the pipe character as a separator here. And then we are going to spread those entries out as arguments into our getSeconds function here. Running this through Node, we should now have our times in seconds. Alright, now we are getting somewhere here. Alright, we are going to go ahead and take that array and store that in times in seconds. Now, what we need to do, we need to take from this array, we need to calculate the range, the mean, and the median. So what we're going to go ahead and do is, first we're going to go ahead and determine the range here. And in order to do this, in order to calculate the range, we need to first get the minimum and maximum value of our times here. We're going to do range, and we're going to do math.max. We're going to spread out our times in seconds. And then we are going to subtract that by the return of math.min times in seconds. And in so doing, we should now have our range. Next, let's go ahead and calculate the mean, the average of our times here. And we can do that by doing this. Const mean equals times. I think we are going to need to floor this here, because in the remarks section here it says if a result in seconds is ab.xy, it will be given truncated as AB. That tells me we are going to need to floor this. So math.floor. And we are going to pass in the return of the reduce method here. Times in seconds dot reduce eval plus eval 0 divided by times in seconds dot length. That should be times in seconds here. Alright, so what we're doing here, we are adding together the times that we calculated up here using the reduce method. We're taking the return of that and dividing that by the length of the times in seconds array to get the average time of these times here. And then we are flooring that here, and we're storing that in our mean here. Finally, let's go ahead and calculate the median. Now, this will work in one of two different ways, depending upon if there are an even number or an odd number of times. In this particular case, we have an odd number of times here. So, alright, we're going to do let median. We're going to set that for now to null. If times in seconds dot length modulo 2 is not equal to 0, that means this is an odd number of times, and we'll have an else block here. We'll work with that later on. But first, we can go ahead and calculate the get the element, the middlemost element of our array here. And we'll calculate that by taking the constant mid index, and we are going to go ahead and we are going to need to sort our... Now for this, we are going to need to sort our times here. Actually, no. No, we don't need to do that here. Anyway, we'll do times in seconds.length divided by 2, and we're going to floor that here. That should give us 2 here, and that should give us element number 2 right here. And we'll go ahead and set median to times in seconds at that index. Now, we need to account for instances where we have an even number of entries as well. So I'm going to go down to our tests here. All right. I have 5 entries here. 1, 2, 3, 4, 5, 6, 7. We have 7 entries here. All right, we're going to go ahead and grab this string here. Do a console.log stat. We're going to pass that in here. We're going to omit, however, one of these times here. In so doing, we should have an even number of times right here. All right, let's go ahead and account for that here. All right, we need... Now, it says here, if there is an even number of observations, then there is no single middle value. The median is then defined to be the mean of the 2 middlemost values here. Here we have 6 elements here. So what we'll go ahead and do, we'll take the length of this here, which should be 6, and divide that by 2, and we will get 3 as a result here. Element 3 is right here. And so we should get that and the element before it here. And then we'll go ahead and calculate the mean between the two. If I'm not mistaken, that should be the difference of these 2 times right here divided by 2. Yup. That's the median. Yep. 3, 5, 3, 5, 9, 11. Wait, these are sorted here. Yeah, okay, this does need to be sorted here. So what we'll go ahead and do, we're going to take the resulting array from our times and from our map method here. We're going to run that through the sort method. And we are going to sort these times in ascending order here. Alright, this should now be correct here. Now, what we'll go ahead and do, we're going to go ahead and get const mid index right to mid index equals math dot equals time in seconds dot length divided by 2. Now, this should be an even number, so we shouldn't need to use floor here. Alright, we are going to go ahead and get the 2 times in the middle here. Const right time equals times in seconds at right mid index. And then const left time equals times in seconds right to mid index minus 1. Now, we will go ahead and take these 2 times, add them together, and then divide it by 2 to get the mean between the two. So median equals math.floor, left time plus right time. I'm going to encapsulate that in parentheses here. Left time plus right time divided by 2. And then that should be the median right here. Alright. We're going to go ahead and return these in a pair for now. Return, I think it's range, mean, median. Alright, we're going to go ahead and test this out here in Node and see what this looks like here. Now, these are returned in seconds, but we're going to need to return these back in the format that this Kata solution was fed. And that would be the hour pipe, minute pipe, second pipe. And that's going to call for another helper function here. Const get HHMMSS. And we're going to have our seconds here passed in here. Now, I think seconds is alright, let's go ahead and pull the node repo up here for a second. 2838 modulo 60. That would give us 18 seconds left over. How about 2838 divided by 60 modulo 60? Yeah. Math.floor 2838 divided by 60. That should give us 47 minutes. How about math.floor 2838 divided by 60 divided by 60. Should give us a 0 right there. Alright, let's go ahead and implement that right here. Const HH equals or rather let hours equals math.floor seconds divided by 60 divided by 60. Let minutes equals math.floor seconds divided by 60, and then let remaining seconds equals seconds modulo 60. Now, each of these needs to be returned in double digits right here. So we are going to return the following. If hours is a less than 10, then 0 hours, otherwise out. Otherwise hours. Then we have a pipe. Minutes is less than 10. 0 minutes. Minutes. And then another pipe. Remaining seconds is less than 10. Remaining seconds. And it's a little convoluted here, so let me explain what's going on here. We're returning our hours, minutes, and seconds here back, formatted in the hour pipe, minute pipe, second pipe that we were given up here. Only it needs to be returned as 2 digits each here. So if we do this for each of our hours, minutes, and remaining seconds here, if it's less than 10, then we need to prepend a 0 before our hours, minutes, and seconds here respectively. Otherwise, we just go ahead and give us the hours right here, minutes, seconds, and remaining seconds right here. Alright, let's go ahead and test this out here. Get HHMMSS range, get HHMMSS mean, and get HHMMSS median here. Alright, let's punch this in a note and see what this looks like here. And we have a problem here. Alright, what seems to be the problem now? It probably needs to be modulo 60 here. Yep, that seems to have fixed that issue there. 3515, 132, 34. Now, we need to return this as a string, this particular string right here. So, we'll do another template string, range, and in this first placeholder, we'll have our get HHMMSS range, average, get HHMMSS mean, and median. Get HHMMSS median. And that should do it here. Alright, let's go ahead in our test here. Let's bring back that 7th time that we had right here. I'm going to hit copy. Paste. And let's check that against that one. Range 003117, average 022618, mean 022200. And that is what we want here. I think we are ready to punch this into Codewars to see what this looks like. We're going to copy, paste. We do need to handle an edge case up here before we submit this. If our string is empty, then we return a blank string. Let's go ahead and reflect that in the Kata here. Alright, let's go ahead and run these tests here. And we have an error here. Because we forgot the colon after median here. Yeah, let's try that again here. Now let's hit attempt. And we are good. There is always a sense of accomplishment that comes with solving a G964 kata. I gotta hand it to him, this was a fun one. In hindsight, I knew I was going to be sorting our times and seconds in ascending order, so I really didn't need to find the minimum and maximum value of that sorted array when I was calculating the range. I could have just indexed the sorted array at index 0 for the minimum and the last index of the array to get the maximum instead. Given 2 strings representing valid IPv4 addresses, the goal of this kata is to calculate the number of IP addresses between the 2 given addresses, including the first but excluding the second. All inputs will be valid IPv4 addresses in the form of strings, and the last address will always be greater than the first one. Now, I won't be validating these IP addresses here, but I did so in a previous episode of Versus Codewars. I will put a link to that episode in the description box below. Now, Recall that these IP addresses can also be expressed as 32-bit unsigned integers here. Alright, I will demonstrate how to arrange these IP addresses as such. Let's go ahead and get started here. And I will need the help of a helper function here. So, let's do this. Const get IP as integer. And we will go ahead and pass in our IP right here. Alright, first we need to go ahead and take that IP address and split it into its individual octets with a period separator here. So const octets equals IP.split with a period separator, and then we are going to parse those as integers here. Do that as such. Parse int octet. Alright, what I think we'll go ahead and do here we're going to go ahead and have a we are going to go ahead and return. I think we use the OR bitwise operator here. We return I think it's octets. First, it's octets at 0. Shift left by 1624 bits. And then we do an AND bitwise operation like this. 0 times FF. I think that's how that's done. Then we take that, and then we use an OR bitwise operation here. We're going to need another layer of parentheses here. We're going to run that through the OR bitwise operator. We're going to do octets at 1. We're going to shift this left by 16 bits. And we're going to AND that by 0 FF. Another OR operator here. Octets at 2. Shift left by 8 bits. And 0xFFFF. And then finally, I think it's octets at index 3 and 0xFF. I think this is right. I hope it's right. Let's go ahead and test this out here. We are going to go ahead and return get IP as integer, and we are going to go ahead and pass in our first IP address. Let's test this out here. Console.log get IP as integer. Let's do 0.0.0.50. Let's go ahead and test this out. Node count IP addresses. Get IP as integer is not defined. Oh. IPS between, actually. Alright, let's try that again here. Octets. Spelled octets here. And we should get 50 here. And we do. Let's try 10.0.0.50. Alright. I'm hopeful here. Let's do 0.0.1.0. That should give us 256. Yep. Alright, with that being said, we should be able to get the difference between our two IP addresses here. It says here the last address will always be greater than the first one, so there is no need to do any min-maxing here. Alright, we'll do get IP as integer, we'll pass in our second, and then take the return of that, subtract from it the return of get IP as integer, passing in the first IP address. Alright, let's go ahead and test this out here. Got a couple of IP addresses I'm going to copy over from the Kata instructions. I'm going to paste it in here. And we get 246, and that is what we want to see. How about this one right here, 10.0.0.0 and 10.0.1.0. $256. Alright, how about this one right here? 10.0.0.0 and 10.0.0.50. And we get 50. And that is what... And I think that is all she wrote here. Let's go ahead and punch this into Codewars to see what this looks like here. Let's run these tests here. And we are good. I mentioned during this Kata solution that an IPv4 address can also be expressed as a 32-bit unsigned integer, in addition to its string form dots and numbers notation. Now, the string form of an IPv4 address can be expressed as 4 numbers separated by periods. These 4 numbers are referred to as octets, and they correspond to what the bytes of the IP address in its integral notation would look like here. The first number, the first octet here, the leftmost octet, would represent what the first byte of the integer would look like. The second leftmost, the second octet, would be what the second byte looks like. The third octet, the second rightmost octet, would be what the third byte looks like. And the fourth octet, the last one, the rightmost one, would be what the last byte looks like. Now, what you saw here in the helper function was a way to use bitwise left shifting and the use of the and or bitwise operators to convert the dots and numbers notation IPv4 string into the 32-bit unsigned integer equivalent of that IP address. Now, a little bit of a footnote here. My system here, and I think Codewars, also runs on a little endian notation system here. If you were working on a system that was on big endian notation here, the bytes here would essentially be swapped. And that is going to do it for today's episode of Versus Codewars. If you like this video or you learned something new, drop a like and subscribe to this channel to see me take on more coding challenges on Codewars. As always, if you believe there is anything I can do to improve on my code for the better, feel free to drop a suggestion in the comments section below. Also, if you are a Kata author on Codewars and you would like to share your authored katas with me, feel free to drop links to those katas in the comments section below, and you might see me try to solve a few of them in a future episode of Versus Codewars. I hope you have a wonderful day, and I will see you on the next episode of Versus Codewars.